half-life period represented by T half, it is defined as the time required for a radioactive material to disintegrate to half of its original amount. That is, let us say we have a radioactive sample, radioactive material which is initially 10 grams. After some time, let us say after time t, this radioactive material spontaneously emits alpha, beta and gamma rays, therefore its mass gradually decreases, and after some time, let us say it becomes 5 grams. This time required for the amount to disintegrate to half of its original amount is known as half-life period, and it is represented by T half. So that is what we mean by half-life period of a radioactive material. The time required for a radioactive material to disintegrate to half of its initial amount is known as half-life period. We have an expression for this one in terms of disintegration constant or decay constant. We will see that now. Let's start with the law of disintegration, that is n is equal to n naught into e power minus lambda t. It gives you a relation between the initial number of nuclei of a radioactive material and the number of nuclei at any instant of time, and in terms of decay constant lambda and time t, exponential decay, that is what we call radioactive disintegration law. Now let us say this to be represented with equation number 1. Next, according to our definition of half-life period, the time required for the radioactive material to become half of its initial amount. It implies that if you take the ratio of n by n naught, this should be equal to 1 by 2, half of the initial amount, when t is equal to half-life period, that is t subscript 1 by 2. So n naught represents the initial number of nuclei of radioactive element, and n is the number of nuclei at any instant of time. That ratio to be equal to half when time is half-life period. In such case, if you substitute these values from here, equation 1 gives you n by n naught equal to e power minus lambda t. In place of n by n naught, we can substitute 1 by 2, and in place of t, we can substitute t half. So this expression becomes 1 by 2 equal to e power minus lambda t 1 by 2. So from that, if you can write this further, e power lambda t half is equal to 2. We made this as plus, and this will become reciprocal, that is 2. That is how we got that expression. Now proceeding further, we can write this expression as lambda t by 2 equal to logarithm base e of 2. Now that is the expression. From that we can write equation for t half, that is half-life period, as log base e2 divided by lambda. The value of log e2 is 0.693, therefore that becomes 0.693 divided by lambda. So in this way you can write expression for the half-life period in terms of decay constant lambda. If you know the lambda value of any radioactive material, you can determine its half-life period using that one.